So maybe in the meanwhile, I thank you, Dr. Hamad, very much for the invitation. It's indeed a brilliant idea to put all the expertise in one package, and make it very much flat for all and share it with the people.
Thank you for taking the time. I know today you're not feeling well. Despite that, you are with us and doing this amazing session.
Thank you. Yeah, I took a couple of tablets and it's okay now.
I need just a few minutes. I'm just sending this one to make sure we are ready. We have around 90 on LinkedIn and more, I think, maybe on Facebook. I'll check it later. And we have people with us here on Zoom. So I think 1 minute and we'll start. Okay, so thank you everyone for joining us today. It's another session which from one of our experts, and today we have Professor Muntasir Qasaima. He is the Associate Provost for Research and Academic Development at Abu Dhabi University. He joined Abu Dhabi University Electrical and Computer Engineering Department in 2011, in which he also holds the position of Professor in Electrical Engineering. As both an academic and professor and inventor, I have said all of this, Professor Qasaima is dedicated in pioneering research, fostering innovation, and establishing research centers. Notably, he played a pivotal role in establishing the Applied Research Center at Abu Dhabi University, including the first quantum computing academic laboratory in the MENA region. His impressive track record, including significant contribution to original scientific research and 9 US registered patents in cutting-edge technologies and invention. Along with his collaborators, he is known for his groundbreaking work in developing electro-optics quantum technologies using 2D graphene material. Earning his PhD in electrical engineering from Dalhousie University in Canada, Professor Qasaima then received a prestigious METAC Elevate postgraduate fellowship from the University of Ottawa, Microwave Photonic Research Laboratory. He serves on advisory board for high-tech companies and editorial board of prestigious academic journals, including scientific reports by the Nature portfolio. So we are really pleased today to have Professor Qasaima with us today. He will be talking about bridging innovation. You will see in this presentation and talk lots of important things that you can take away from here. And we would welcome your discussion, questions. You have the Q&A. If you have questions, you have the chat you can do. and also you can raise your hand. I'll be watching also the social media interactions, and we'll try to address your questions and comments as much as we can. The floor is yours, Professor Montasser.
Thank you so much, Dr. Hamad, and thank you so much for your encouragement all the times and facilitating the technology for all of us. I appreciate it. We are going to be discussing today about bridging innovation. We will focus into impactful research. Having that said, we will talk about technology transfer and the related techniques and how technology transfer can be done. We will not talk research today. We will talk about research and the things that would help into enhancing the utility of research, how make research into much more impactful situation for the community. So allow me first just to a little bit reflect into my background that will help into talking, about the other things. Nothing to brag about. I came from Jordan, where I earned the Bachelor of Electrical Engineering, so I'm an engineer by training. Then I moved to Italy. I got my master's from there. Then I moved to Canada, where I got my PhD education, as Dr. Hamad mentioned, and my postgraduate. Then, for my entire career, I was based in Abu Dhabi. It's like a quarter of my life now, and my entire career was in Abu Dhabi University, starting from assistant professor up to the associate provost for research and innovation. My research interest starts, like at the time of the PhD, it was about fiber optics. That was about 15 years ago. It was a hot topic at the time. And then 5, 6 years, the field starts to get matured. I moved into plasmonics. It's at the extension of the field where you have the waves, the light propagating at the chip scale, classical basis, meaning to say, you have a strong field, you have a strong signal. Then I moved to quantum devices. And when I moved to quantum devices, I was associate professor at that time. And I have to learn quantum physics from scratch. I have to buy an undergraduate textbook, read it, then move into a graduate textbook, read it, then move into papers and move into production. And at that time, 2019, I started to produce my first patent was after I moved into the quantum devices design. And now where I'm, let's say I'm start to age in my career, I'm keep moving. I'm moving to quantum computing. Why I'm mentioning that, it's the message from here is that as an expert, as someone who's really very much competent in your own field, you shouldn't limit your capabilities. You shouldn't limit your interest into what you really, really know. You should extend your capabilities. You should manage from one field into another. And this is really very much helping into utilizing your point of view in a different place. And, that's an innovation altogether. Innovation is bringing two things that are not really related and marriage it into make it very much fruitful. And we'll tell more about that. So my field now is quantum devices and quantum computing. Those are based into quantum physics, which I wasn't even educated, about. I did not, until now, electrical engineering, for example, curriculum does not include quantum physics principles. So spent 15 years, almost 15 years at Abu Dhabi University, and sharing all experience, building the career. It was a very much a great journey. That at that time when I joined the electrical engineering department, it was a very young department with a couple of students and a few faculty. Now it's growing to be very much successful. The university itself is really exponentially growing. We have 5 colleges. We have tens of undergraduate and graduate programs. We have, about 7,500 registered students. So the university itself is a success story. And if you're going to be talking about the reputation and the academic standing by the university is getting from good to a better. And that is, again, something that we can learn from. The university itself is moving from teaching into research. And now we are thinking about not just high quality research and impactful research. Some research that can be, implemented for the community, help the community, the local and the global community. So, for example, we are now number 58 ranked number 58 in Asia, according to the Asia rankings. And we can tell more about other, excellent aspects for the university. But just to give you a rank just to give you an idea that the right place with the right time, with the right people, you make the right success. If we're going to be talking about the ADU research, we are very, as a modern university, we are having a multidisciplinary research nature. We have in the entire spectrum. Our publications are very much international. So, for example, if you look at our publications 2023, more than 80 or about 80 is with international collaboration. So we are having a very much standing international collaboration, and that gives us a solid ground to build upon, to think into moving into the next stage, how to get into an impactful research rather than only spotting into a high quality research. So if you look into the big image, it's the ecosystem, the economic ecosystem. The economic ecosystem that includes educational institutions, research institutions, governmental agencies, investors, industry, legislations, initiatives, non-governmental agencies. Is a very complicated scene. And we, as an academic institution, we are very little. We play a very important role, but we are part of a very complicated integrated system. So it's very much interested for us as people from academia, as researchers, to optimize the coupling, if you wish, to optimize the technology transfer from this little institution representing the higher education sector into the entire economic ecosystem that really works at a very complicated system. It's not only, it's not only impact, but also we are subjected to the ecosystem development. There is kind of a complicated or a complex relation between who leads who. Does research leads development or development leads research? And the truth, it's a very complicated relation. And, they act at the same time in a very coupled manner, and hopefully with the right strategies from the two sides moving forward. So today's session mostly will be about 4 aspects. First, we will talk about research. We'll talk about research and development, the funding allocations for different sectors of research, and we'll try to define what gap we have, and we'll try to bridge that gap. And we claim that it's the technology transfer is one of the things that we need to look at to bridge that gap. And technology transfer has many different stages, a very complicated process by its own, and there is no clear definition, or let's say a cut-edge definition for the technology transfer. But we know that technology transfers start with intellectual properties from our side as people coming from the higher education. And that one, the patent is the invention. It's the legal copyrights for the invention, but invention itself needs to be moved to innovation. We need to get into invention, and integrated with the system, implemented to the system, the economic ecosystem. So have moving from concept into product, you need innovation. So we'll talk about innovation. We'll talk about what kind of measures we have for innovations. And the last part is about bridging that gap that we were spotting. Okay, fine, you are having different aspects for research. Okay, fine, we can, you have a process of technology transfer. What kind of channels that one, or we would like to train ourselves, train our students, train our peers to bridge that gap. Just startups, the way that startups work, effective pitching. And we'll close with a topic that I love a lot, which is the blue ocean strategy. So research, what is research? According to the, very much well-known scientist, Albert Einstein, he has a very famous say. He said, if we know what we are doing, we would not be able to call it a research. That's a very vague statement, saying that you really at the moment that you are tackling the problem, you don't really know what you are tackling, or you don't really know where it hits. And this is very much true. But this is, ladies and gentlemen, more into the basic research. Basic research where you are experimentally or theoretically work and aim to acquire new knowledge from scratch. Very much important sector. It's, all the revolution that we see right now with the, We are leveraging the technology nowadays started from the very basic research aspect, but there is an applied research as well. And applied research where you are tackling a certain problem, you are having a certain application in mind, and you are using techniques and science bases and knowledge and patterns, technology, they say knowledge patterns to get into a certain applied outcome. And then we are having development. Development where you have a systematic work. Development is that you have the product is already there, and you would like to leverage the product from business aspect point of view, from application point of view. So indeed, there are different types of research aspects. We can put it in different categories, but today we are looking into basic research, applied research, and development. As we said, we are talking about research. So let's look into that, from the angle. Let's look to that three different sectors from the angle of investment, how much money it's being invested in these three different, sectors of research. If you're going to be looking into the United States research and development spending for the year of 2020, you will find that a lot of money, most of the money is being dedicated to development. Less than that is for applied research and a little bit less for the basic research. And of course, that can be, understood from the angle that this is a market. This is a capital market where you really invest into the product or into the sector that returns the most and that ensures the sustainability. So having that said, it would be important for us to understand as a higher sector people our role, to which extent we are really doing in the basic research, to which extent we are really doing in the applied research and development as well. Putting in mind that we have, the market share for the development is more than twice of the applied research and the basic research together. So if you're going to be looking into the basic research spending for the same year in the United States and look into it into different sectors, from government to business to higher education, you will find that higher education is getting some, percentage, good percentage, maybe about 80%. Some businesses and governments are dominating. They have, that they control the capital, and they have the way that to direct their basic research in a certain way that it will serve the economic development. We do, the higher education, as all of us know, we do research first to train ourselves. Second, from academic point of view, in many cases, we start from scratch, and it leads to great inventions. It leads to great discoveries, but it's not directed for economy, and that's still good. It's still needed for the big ecosystem. If you move to the applied research, you will find that, higher education is having much less share, and businesses is really taking over. So when it comes into the applied research, where the research is really directed to certain industry, is really close to be applied in the near future in comparison to the basic research, all of them at the end of the day, hopefully will lead into elevating the humanity and getting into products and getting to the economic developments and feeding into the ecosystem that we just mentioned. But the higher sector, and we are talking about United States here, which is a very much strong educational system. The higher sector in applied research is really minimal. If you move into the development, you'll find the higher sector almost the higher sector contribution to the development, it's almost null. It's not there. It's being dominated by businesses. So there is a gap here, and we define that we are really, as people from academia, want to think into how can we leverage the nature of having, the nature of having more money into, let's say, more capability. It's not about money, it's about the capacity. It's a stronger capacity dedicated for development and dedicated for applied research. So the answer could be for technology transfer. We need to learn how to move from, first of all, we need to foster efforts into the applied research, and higher education is doing well into applied research. Of course, more efforts can be fostered into that, and of course, we still need the basic research. Nothing wrong with the basic research, but the tricky part, how to move from applied research into the development sector, moving from applied research into the product. If you look into the technology transfer carefully, we will find that things will start with applied research. And if you have inventions coming from the applied research, you're going to be having the intellectual properties, the patents, the copyright. This is the knowledge creation stage. And then you need to integrate it into the industry for the sake of testing, for the sake of, having a feedback, maturing your technology. And that, requires intermediate agencies. And of course, there is a measure of how mature is your technology, the technology readiness level. We'll talk about it. And finally, the entrepreneurship comes where you need, okay, fine, you have integrated your product, you have tested, you have matured it, the technology is ready to go. How to launch it into the market space? How to get your product from the IP stage into the product stage? This is what I'm going to be a little bit talking about today, and we call it technology transfer. I would like to mention here is that the things that we are talking about today, it's not science, it's not mathematics, it's not physics. So it's not facts, it's opinion. That's how we see it from our angle. Maybe someone else will come from a different angle, will have some changes, some additions, so it's just something that we would like to share about. It's based into the literature. So these things are agreed upon to a good extent. So we need to talk a little bit about technology transfer, and we will start into moving from an idea, applicable idea, into having a patent, creating a patent. So the second phase of today's class, how to get into your idea patentable, and why is that good? How you can do that. We will start here looking at the revenues that United States, universities are getting from 2008 to 2018, only leveraging the patents that they have by, having revenue from the licensing, what they have as registered inventions. And the number is astonishing. It's about $3 billion. It's a really huge amount of money. We take it as a witness of how worthy is, having your ideas patentable. How impactful is your inventions coming from academia. And you know what? Look at this. Here is historic patents. To the left, the Thomas Edison's patent for the invention that he has for lamp. Second, Carl Benz patent for the car, the Mercedes-Benz. Nikola Tesla patent for the electric motor. These patents change our life. So it's not about, we are looking to the angle into how the market sector look like, how to capitalize into the capacity that we are having. But in fact, these kind of inventions are life transformation. It transforms our life transformative. It elevates the people's life. It's very much interesting. We would like to magnify that. We'd like to get more into patents. We'd like to get more into technology transfer. If you continue and look here, for example, this is the number of recently patents, and I was biased to myself. This is our recent patents, just 1 month ago, and the wave continues. We have maybe more patents now, and maybe less critical patents now because the technology is very advanced, but it's still very much important and still moving our life forward. So the question now, how can you move from a good idea into a patent? If you have an idea in hand, how do you know it's patentable? And if it is patentable, how you pin it down, how you make it as a registered invention for your own. We have chosen to look into this paper by Nature. It's an opinion of 5 experts worldwide, and these experts share their opinions. The first one is John Gray. He's from UK, an European patent attorney, and he just said that we'll find 3 important elements to make an idea patentable. The invention must be new, and that's true. By the way, for a patent, it doesn't need to be complicated. It doesn't to be based into a complex science. It could be based into a very simple idea or a very complicated idea. The most important thing, it reports a new finding. So it has to be, the invention must be new. There must be some invention steps, there must be non-obvious steps in the invention. So if you are having a new idea, but the idea is straightforward, that's not a patent. It has to include some creativity inside, and the disclosure of the patent must be sufficient or a skilled person to produce the invention with only routine efforts. He says the number 3 is that the patent should be repeatable. So It's new, it's non-obvious, but someone with some ordinary skills, once it's known, can reproduce it. According to the John Collins, and he is an advisor at the Innovation Founder in London, he said that to get a patentable work, you need to have a problem looking for a solution. So start from the problem. That's one strategy many people do. You need to find what's already been done. So if there's a problem, see what others have done. You don't need to reinvent the wheel, as people usually say. You need to identify the potential clients. Here is talking about patent with a potential. It's not necessarily to be patent with the potential to get your patent registered, but it's so smart to do that, to spending money and efforts, do that when you are having potential market for your patent. And in mentorship, his mentorship is very much important. If we move to Anne Joan, and he's from Indonesia, and he's a very, very well-known inventor as well. He says that you need to solve a problem that are close at hand, be pragmatic, discover what's already there, and regularly communicate with businesses to integrate your patent with, with the market that you are having. Christina, she's from the MIT, and she says that make early contact with a technology licensing officer so you know what's right, what's wrong. It's advantageous to gain IP as soon as possible. So there is a different type of patents. There is a complete patent, and there is a provision patent where you need, sometimes your topic is very hot and you need to register your patent right away. And lastly, the collaboration between scientists and entrepreneurs is very important. My insight here, and I have like a record of 10 granted US patents. My insight here is three things. Because I'm a scientist, my angle is a little bit different. First of all, you need to stay updated. You need to stay ahead of the knowledge curve. Second, you need to focus on hot topics. That enhances your chances. And most important thing, master two fields at least and merge them together. Leverage the interdisciplinary expertise. My experience was I was an trained electrical engineer. Then I cannot say that I'm mastering quantum physics, but I studied quantum physics, and merging together, patent starts to born easily, because the physicist people are not really aware of the engineers' techniques, and engineers' techniques are not really aware of the how the physics goes together. So be updated, focus on hot topics, it helps, and master multi-fields. If you can mastering two fields or more, your opportunity is really, really very much high. So having that said, looking at these things, you are moving from an idea into a patent. But that's not the story. Now we need to move from a concept, from a patent, into a product. And this is another very difficult, I don't say too difficult, but the very demanding process. Having a patent, you are having a proof of concept. Launching your concept into the market, you need to have a product. And here, what you see here is the minimum viable product. It means that the product that can be attractive to customers with the minimum properties. Of course, doesn't mean that you cannot have a maximum viable product, but it's always recommended you start to having a minimum viable product. So moving from idea into the product, you need to move from a lab test into a full system that is being tested, including the big ecosystem image, including the clients, including the market, including the competitors, and so on and so forth. And doing so, you need to move from the proof of concept by having a prototype, maybe having a pilot project, funded by some agencies to produce the minimum viable product. The product that is acceptable, it can be purchased, it can be beneficial to the client at the least properties, not fully prepared product, because if it's fully prepared product, there is no guarantee that it's really market demand, it fits the market demand, and that will cost a lot of money. We'll talk about that more. Important thing, prototype. It's not necessarily to be a physical prototype. It could be a business model. So, for example, if your concept is SaaS, which is software as a service, you need a good business model to get into the MVP, and then you move into the implementation into the market. So it's a long process. It's very much exciting though, and if you have a strong ecosystem, you're going to be having the tools the investors, the accelerators, the incubators in your, in your ecosystem implemented to help you moving forward. We'll talk about that in the upcoming slide. So moving from concept into the product can be measured by what's called technology readiness level. If you are having a patent, it means that you are in the technology readiness level, maybe 3, maybe 4. No, most likely you are at the research to prove feasibility. Technology development comes later. So universities are always stuck from TRL 1 to TRL 2 to TRL 3. Companies, giant companies or well-established companies that are in the business already, they are always working at the last technology readiness level, where you have the system test and you have the launch and operations, and maybe at least TRL 8, where you have the system subsystem development level. So there is a gap in between, and all, I don't like to say the devil, but all the tricks or the challenges is how you're going to be moving from TRL 4 into TRL 8. We'll talk a little bit about it, but there are some tools, including startup companies that can help maturing your invented technology. So if we're going to be moving forward, intermediate institutions, which is part of the ecosystem, would play the role to match the TRL from 3 to 8. These could be, we did not talk about the economic ecosystem, but if you look into the economic ecosystem, it has investors, it has research institutions, it has manufacturing utilities, it has legislations, it has government entities. Mostly, all of this I mentioned is mostly, typically, it's centered around government entities. Government entities are the ones that are funding, that are putting the legislation, that are resurrecting the process. So you're going to be having some accelerators related to the government, and innovation centers that should be integrated with the university nowadays to help moving the research outcomes into a market fitting, into a company, to have it matured from TRL 4 up to TRL 8 and move on forward. So yeah, this is a very important component nowadays from the university is not producing knowledge, is not producing papers only nowadays. It's more than that. It's part of the ecosystem and needs to be optimizing the technology transfer forward. So, innovation centers, we have one at our university, and we're still optimizing that process. This is a new concept. It shall has incubation and shall has acceleration, and we need to look at the strategies, how to move your idea from the very much premature situation to the premature situation. This is a complicated scenario. One of the very much important operation is starting up your own business, startup companies. Startup companies are very much good mean that can bring your component from your product, your intellectual IP, from a very much let's say initial situation with the TRL3, hopefully, and we'll talk a little bit now about how to do that, into the TRL6 and move on forward. And the innovation centers and the non-governmental agencies and the governmental agencies for acceleration should be helping. That's how the ecosystem works. So you as a student, or you as an inventor, should be looking for these kind of entities and interact with them. So first of all, what do you mean by a startup company? Can you say that about any company is a startup company? Is a supermarket is a startup company? The answer could be yes or no. Startup companies have a very, this is not every features of the startup companies that you see here, but they have a very distinct properties. One of them, besides that the innovation is at the core, besides that you have a minimal, starting cost, like the cost is really not too young, and usually they are new and young. The most important, in my opinion, properties for startups, the scalability potential. So when you are setting up a business, the business initially is, in principle, the business model associated with the startup company is scalable. You are producing a software that serves a certain we call it beachhead or certain sector, certain place, but the same software can be later scaled. The same resources can serve a much larger number of, of customers. So scalability and quick growth are the very much fingerprint for startup companies. So, for example, if you're talking about a supermarket or let's say a pizza shop, I met a guy, a gentleman who owns a 40 a 40 store for pizza shop. And I told him, how did you manage doing that? He said that we have a very innovative system of producing the pizza in 5 minutes. And I met him in a workshop where he want to move from 40 to 700 in India. He's based in India. So this is a startup because it scales up, it grows dramatically, and so on and so forth. So having that said, startup company is a young company that has innovation at the core, and the business model is scalable. It can be potentially grow, can be quickly grown. Potentially, it can be grow in a very much dramatic manner. But the negative side of it, it has a high risk. So from many startups, you have a few startups surviving, but that doesn't mean you have a wrong business model. It means that all these kind of entrepreneurs learn that if your startup is down, you need to change your business model. You need to do market business. They call it the PMR, the primarily market research again, and reactivate it. That's how entrepreneurship happens. And if I put here, you see a unicorn. Unicorn is the startup company that reaches $1 billion cost before public offering. So, and there are many examples of it. If, ladies and gentlemen, if you look into the history of startups, you will find startups are very, very important in our current life. Walmart is a startup. Microsoft was a startup. They were a startup. Apple were a startup. Google were a startup. So these are very important companies, very successful from the 20th century. If you look at the 21st century, LinkedIn is a startup, used to be a startup. Tesla, Airbnb, WhatsApp, Instagram, and the list goes. So startup companies, or startup approach, I should say, have proven its competency, have proven how important is this approach. And all of these, if you look at them, they are innovative at the core. They are technology driven, they are scalable, and they start from a very low cost. If you look at the current startups on rise, of course, you're talking about artificial intelligence. Look at the ChatGPT, look at, the market size of these companies. It's billions of dollars. And you know what? They are on rise. So they are just starting right now. So, and people, they call it this one SaaS, or if you add AI, sorry, artificial intelligence powered SaaS or software as a service. But for me, I see it also not only a software-based company, it's a soft investment as well. Because you don't really much to have the infrastructure and to invest into the infrastructure. These kind of ideas, if you have really an innovative concept, can fly very fast and can fly very efficient. So if you look into startups spent from universities, these are the United States based universities, there are plenty. If you look into the MIT, for example, for the area between, for the time between 2008 until 2018, 10 years, 244 startups. So startups in principle is something that inventors coming from academia, students, researchers, faculty can do. And they are proven to be very, very, very much successful. Now, if you look into the total global investment in startups for the year from 2000, this is for 2020 and 2030, you're talking about $300 billion worldwide. So there are, people, our investors are taking it as a very much serious business. They know that, in startups, if it goes successful, you could, you have 200x, or more than that. You can have an exponential growth in the revenues. It's very much appealing approach. Now, if you look into the startup funding, you as an innovator and you want to get into your startup, all startups, ladies and gentlemen, start from a seed funding. Seed funding happens to a good idea. If you are looking for a seed funding, usually it's less than $1 million. That means you have an idea, but you did not implement your idea yet. If you are implementing your idea and the idea works fine and you need to scale, you need to attract more you need to scale your business, you need to attract more clients, so you need to have investments. You go for Series A and you get a couple of millions of dollars, then Series B, then Series C. Of course, who funds you are the venture capitals, the investing companies. And why they give you money? Because they get equity, they get portion of your business. So you might start with 100%, and you end up, when you go into public offering, to owning maybe only 50%, because you have acquired all of this funding. But that's a lot of money. I'm not aware of who's the most rich person on earth now, but I know that the owner of Amazon, a very rich person, and he owns only maybe 50% of Amazon. Doesn't mean he owns Amazon 50 or 51. Why he lost, that kind of portion? Because of seed funding. Because of the funding, going from seed up to, maybe not everyone goes to Series C. Some people go to Series B, then go to public offering. So to do that, that's the name of the game. You need to be attractive. You need to acquire, investment into your business, and after that, based into equity risk equation, you might grow most likely if you are doing the job right, or maybe you need to redo the job. Redoing your approach, and you redo your business model and all of the things together. So the question now, how you can acquire the seed funding? The answer is, you need to be prepared. After having your invention, after having securing your ideas, you need to prepare, excuse me, a very convincing business pitch. You need to this is we call it elevator pitch, and it came from in New York, when you need to convince, you need to meet very, very, very busy business people. The best time that when they are using the elevators. So maximally you get 50 seconds. If you are getting into a very one of these towers in New York. So based into that, people develop the concept of elevator pitch. It's like 50 seconds where you need to convince the investor that you are having an idea and the idea is good. And usually, please search the net, and you'll find many examples of doing that. If you have an idea, it's not necessarily to be a patentable idea. It could be a business idea. It could be a software idea. So you need to prepare a pitch where you introduce yourself very fastly. You have to show what's your unique value proposition, your goal, your targeted audience, and your ask. If you are successful to convince the investor, of course, nowadays you can approach them online. So you can prepare your pitch deck, the elevator one, the short version. You can record your video and send it to the companies that of your interest. If you catch attention, then you can prepare the more complete pitch deck, where you need to show your business model as well. You need to show which beachhead market you are having. It means that you have always to start with a very specific customer. You need to develop a persona model, and then choose what beachhead market you have, and then you move into the service available market, the business model, the go-to-market strategy, and the team. And then have your ask, what kind of money you need, for how much equity you have. I hope I'm not running behind the time. And I heard it many, many times from very good investors, is that in many cases, the most important thing is the team. Because in many cases, the idea is clear, but the question, do you have the right team to carry on the idea? Can we, trust having the investment money with the team, and why should we do that? Of course, forming a team is known. You start from forming, and then you get to the performing. So always in your form a team, there will be some difficult times, there will be some disagreement. But if it's objective for the good of the business, usually you get into the performing. And I hear people saying that the more storming you have, usually the more performing you have. So you have more information here. So if you're going to be talking about this is for a business model, the most important thing in the business model, you need to show how much is the customer cost acquisition. The COCA, which is the customer acquisition cost, would be, and you need to know how much would be the lifetime value. So if you have a customer, how much it costs you to acquire this customer into your business, and for the full cycle life with you, how much the customer would be the revenue, how much it would be money-wise beneficial. For example, for SaaS or software as a company, sorry, software as a service companies, the revenue or the lifetime value should be at least more than 3 times of the Coca, according to statistical analysis. Otherwise, most likely your system will fail. So having your idea, you need to prepare, you need to do your, market study, you need to do your business model, know your competitive advantage, plan your go-to-market strategy, prepare your team, and pitch for your idea. It would be great to close with blue ocean versus red ocean. In blue ocean strategy, you create your innovative idea, you look into a new marketplace, you make the competition irrelevant. For example, look at that, companies that, for example, look at Talabat or look at Uber. They make the competition irrelevant for other traditional, food supplier. Why? Because they provided the service that others don't use, that the other don't use to provide. So that make them at the head of the game. If you want to go to the blue ocean strategy, where there is a marketplace that's well known with a known clients, and you need to overcome these people, you need to beat your competitor. That is another business model that works. But for innovation, most of the time, you have the venue to move into the blue ocean strategy, creating your own business sector, creating your own competitive advantage, having a unique selling point, and break the value cost. The money is always there. If you are providing the value, you get the money. So I would like to thank you so much for having this kind of presentation here. It's about thinking in a different way, moving from high quality research into impactful research, pitching your idea. I pitch myself, and I will continue doing that. It's a difficult job. You need to arrive at the right time. You need to arrive to the right person, and it might work at some time and did not work before. So all of these things are subjected to the market situation, the availability of the fund, and so on and so forth. But it's a fun process. It's something that it applies. It elevates people's life, very much high impactful. And I hope that you had some ideas about technology transfer. And thank you so much.
Thank you, Professor Montasser. Now you can raise your hand if you have any questions. I think I answered most of the QA. We'll come to it. But I can see one hand. Debasis, I'll allow you to speak, and you can unmute your microphone and speak, please.
Thank you very much, Dr. Hamad. And at the same time, thanks very much, Professor Montasser, the speaker. I took the opportunity at the very beginning, to say something because I spent several years from the innovations to go to the market and all. So extremely, well prepared, and a lot of information. Actually, what I could see that the beginners and all, they should practice. It has got the data. All your informations are backed by the data from the leading sources. That also I have observed. And it has got the uniqueness of presenting these informations to the needy people who will use it. So thank you very much, Professor. The only point I will say that I would like to give a deep dive into whatever actually is there. So this recording will be helpful for me. Dr. Hamad has already provided a link. Through that, actually, I see that if I can convey something, really, just for exchanging my views on the innovation, the research, and then take it to the practical world, which is very much important, because research cannot remain as a research for lifelong. It needs to be very much applicable to the society, to the life, to the business, and the end users, in fact, actually, in a single word. So that is very good. I am very much impressed, Doctor, for this presentation. Thank you very much.
Thank you, sir. Thank you so much.
Thank you. I really appreciate your feedback. We have Yasamin. You can unmute and speak.
Thank you very much. Assalamu alaikum.
Alaikum salam.
I'm Dr. Yasmin Ahmed. I've previously introduced myself in the last two sessions. I'm chairperson at Architecture Department at Lahore College for Women University. Dr. Montasser, you've been excellent in your deliberation about this startup programs, and I'm quite happy to know that I'm very much on the same page with you for, like you said in the beginning, that it is a set of opinions from your side. I quite agree with your point of view and happen to be stating that yes, this journey from basic research to applied research and then the development, it's actually quite alike that universities are performing quite less in various sections of the globe. However, I have a bit of query from your side if you're easy to respond. Like you mentioned the economic ecosystem. Would you like explaining about any success story that how did you manage the optimization of coupling the institutions? I mean, if it's easy. And if you allow, I'll just add a little bit of background to this question that I am right now in this phase of incubating my department into into our university, not for just selling the products, but to provide consultancy to the regional, local based needs, which is not the private sector only. It is the larger portion of the population which faces disasters, which faces energy shortages, so on and so forth. It will be like coupling with the public sector offices, quarters in Pakistan. Thank you.
Perfect. Thank you so much. Yeah, I totally agree. And it's a tricky process. Once you have your product is attractive for businesses, it would be easier to, it depends on the what kind of specialty you are having. If you're talking about software and artificial intelligence, really you can direct your product into businesses and try to be attractive, try to be competitively advantageous, selling point that you are having. If it's more into the service, or if it's more into a solid state product, moving it into a level that's ready to go to the business is really very much difficult. And you need to approach some governmental entities that are provide support. We have here, for example, some entities that provide support for projects that are health-based in nature. It's towards the health, because they have the philosophy that we need to develop our health sector. So if you are having an idea that has the potential to help the health sector, so they provide you with some funding if you show them the potential, and once you fly, they let you go into the private sector in the end of the day. It has to land into private sector at the end of the day. So it depends on the specialties that you are having. It could be a soft trip where you have a software based, where you need it's easy to be directed into the market, but it's more competitive because the way that you do it, the others is doing it as well. If it's a little bit more into the health science basis from the biological point of view, not from software as a service, because it could be as AI powered system towards the health sector. That's doable as well. If it's not that, then you need to have the help 100%. You need to have the help of a governmental or a family office or something like that, because a lot of investment is needed to mature your product. It won't be really, really potential for market if you don't really invest money and invest time and get into the process of development. I hope I answered your question.
Yes, thank you.
Thank you. So my real message to my fellows here is really learn how to integrate the business components with the engineering, with the science, with everything. And you need to look at the market, the development of the market, the competitors, and don't think that it's never ready. You could start early, and you can learn from the mistakes. You just need to learn how to present your work in a good way, which one to approach, and if you're approaching the wrong entity, that's not the end of the story. It's an evolutional process, and I have seen others doing it, so definitely we can do it.
Thank you, Professor Montasser. Professor Ghassan, I'm sure I can see you are there. If you want to make any comments before we close this session. Thank you.
Thank you, Dr. Hamad, and thank you, Professor Montasser, for an excellent presentation. I was at some stage Pro-Vice Chancellor for Research and Innovation at the University of Salford, and I can understand fully the integration and the coupling of research and innovation. And the way you described it tonight, you've made it so simple, even though it's really more difficult than what you could tend to be. But the way you described it, I'm just extremely happy. And I'm just so proud of you, Professor Montasser, for an excellent presentation. Many thanks, Dr. Hamad, for this idea of investing in our community program or initiative, which is bringing people from across the globe to see what we are doing at Abu Dhabi University, helping our community through the excellent research and innovation being done at the university. I'm really grateful to you, to Professor Montasser, and to the people who attended this very, very important webinar.
Thank you so much, Professor Hassan. Thank you. Appreciate you.
And please complete the survey. I can see many have done, and really very good score. And now it's 97% satisfaction in general, which really amazing. So your feedback will help us improve the future sessions, inshallah. So thank you, everyone. I think with that we conclude, and we will see you next week, the same time, inshallah. Thank you, everyone. Thank you, Dr. Montasser.
Thank you so much.